Hello, welcome to Rendering Graphs Your Way, the case for going custom. I'd like to introduce you to our speaker, Tony Smid.
Hello, everyone. My name is Tony, and for the last 4 years, I've been leading graph visualization at GraphAware. At the beginning of our product, the GraphAware Hume, we used external library to draw graphs, and it was great. It was working fine. But later, we decided to develop our own visualization in-house. And this session is going to be about that. Maybe it should be just called create your own graph visualization or something like more straightforward. So let's get into it. In the first half, we'll just talk about the business context, right? Like, what is the visualization? Is it critical for your product? Is it even a good idea to try developing your own when there is already a lot of other nice solutions that you could rent, that you could license? And if you decide to actually go ahead and build something on your own, we'll look on the technical side in the second part. What challenges are you going to face in that case? So let's start with the business stuff, and let's start with what is the graph visualization? What do we all kind of envision? It's something 2D. It's a picture, right? It shows nodes. Those nodes are styled. They have colors, icons. Maybe they have some badges, different labels. And then there are links between them. Those links also have different styles. And also, there might be groups, there might be some positions, layouts, and we don't want the user to just look at the visualizations. We want to interact with it. We want to, allow the user to select the nodes, move them around, add more nodes, remove them, navigate the camera around, all of this stuff. And graph visualization library is just a piece of software that allows you to do this. Typical product looks something like this. In the backend, okay, there is a Neo4j graph library, graph database, and on top of it, some server run backend, some front end in the browser, and this front end generally generates an HTML, right? Some buttons, some forms, and the user looks at it, reads what is there, and interacts with it, clicks the buttons. And the same we kind of want for the graph visualization, so user can see it and also interact with it. And now the question, well, is it so important? Is it so critical? And I think the answer to this is very straightforward. Imagine your product, your piece of software, without the graph visualization. Is it still going to have the same functionality? And you can answer both ways. For example, the JavaScript IDE, the JetBrains one, the WebStorm, it's a great IDE. And it also has a graph visualization as part of the product. It is this diagramming tool showing you different modules and how they connect together. And it is powered by Wi-Fi. It's an external thing. And if today there was no graph visualization in WebStorm, I would still be using it, and I would still be probably fine with it. On the contrary, if our software GraphAware Hume didn't have graph visualization in it, our clients would be probably very mad, and it would be a big problem. So in that case, okay, it is a critical piece, the visualization there. So fine, should you rent a fully furnished apartment and get a awesome graph visualization out of the box and just start building your software immediately? Or try to build something on your own, which might take a little while? Well, let's look at these two options. Let's first try to see what happens if you get a production-ready solution. And there are a lot of good things that will happen first. You can get something that is commercial, that is a paid SDK. We had a production experience with these three libraries, keylines, Wi-Fi's, and linkers, OGMA, and all were really excellent. Great features, great support, high performance. It was a pleasant experience. And maybe you don't want a commercial product. Well, there are open source alternatives as well. There you might need to do some compromise. Maybe Cytoscape has a lot of nice features, but it's not that fast. On the other hand, Sigma.js or the Cosmograph, they are really, really powerful. You can visualize thousands of nodes. On the other hand, it's just there is not so many features, very very simple styling and so on. So it depends. In general, you get something out of the box. It helps you enormously in the beginning, and you will also gain a support of very experienced developers who would guide you in how to do the visualization correctly. And this library that you choose will influence your code base, your front-end code base. And I'm almost certain this will happen, even if you decide to wrap the library in some wrapper or adapter to maybe switch it for something else later. It's not just the API; it's the mindset, the ideas, how the visualization is done that are going to somehow sink into your code base as well. And it's not a bad thing. I'm just saying it might happen. And then the bad stuff that might happen. Slowly but surely, you will start to find missing features, and you might develop them on your own, which probably is not going to be cost efficient, neither performance efficient. So yeah, or maybe there are extra features. There's a lot of other features that you don't need, but you have them there as well because it's a black box. It's a proprietary piece of software that you're not allowed to touch. Okay, that might be fine, but then there are the business limitations. And as most of these libraries are JavaScript is just being sent to the final user. It's being sent to everybody's browser, and it's notoriously simple to steal. So probably they won't allow you to send to have your visualization somewhere on the public web, which might limit your use cases severely. And yeah, there is still the ongoing cost and ongoing risk. You must realize that there is a company, an organization, which has this leverage against you, which kind of you depend on, right? So let's say you decide to build your own visualization in-house, and you are prepared to spend this money and effort and time on doing it for your graph-based product. Well, if you decide this way, the beginning is probably going to be slow and difficult. The tech stack for building such a visualization is a bit obscure. There are some niche topics if you decide to do your own layouts. Specifically, the force-based layouts, there's a lot of simulations, iterative simulation, non-deterministic behavior, and a whole bunch of unforeseen issues that I will try to highlight in the second part. But it's safe. You invest into your own IP, and it's very, very flexible. You just develop exactly what you need for your product, for your use case. And the optimization has no limits. You can literally optimize your query in Neo4j, your server code, your client code, your visualization, everything is really streamlined. And it's hard to emphasize how important this is. And lastly, the support is next level. Like if this person developing the library sits next to your front-end person, it's just great. They can just talk to each other, and it's much better than any support, although great, that you can get via some external company. All right, so by this point, I hope it's clear that front-end application development, doing your React application or Vue.js, Angular, Svelte, whatever, is something else than the graph visualization development, which is much closer to developing like a game engine or something. So who should you hire to do the job to actually implement this for you? In our experience, it's much better to hire a person with background in computer graphics, a person who knows C++ and knows how to talk to the GPU directly and knows how these highly parallelized workflows and rendering workflows work, rather than hiring someone who is a front-end developer, knows TypeScript, but then you would need to teach them all this GPU stuff. So probably at first, a person who is used to writing C++ is not going to be super happy jumping to TypeScript, but yeah, in the worst case, they can write C++, compile it into WebAssembly, and then run it in your browser, and it would still work fine. So yeah, those guys, they typically work in some game development companies, VR rendering engines, or maybe some graphics software companies like Adobe, Autodesk, working in 3D visualization, doing some automotive or architecture, and yeah, that's the thing. Those are different kind of guys. Those are not your front end people, and rendering, real-time rendering is their go-to Bible. That's the book that hopefully the ones that you hire will own. And lastly, they'll be able to explain to you why they love triangles so much. And yeah, so you get the right people for the job. All right, you have your vision. You know you want to create your own graph visualization library, and you get the people to build it. Where do you start? What is supposed to be the ideal stack for it? Well, firstly, a lot of the moving parts are going to be asynchronous, and having an event-based architecture for that is ideal. So, a typical scenario: click event happens, user clicks somewhere. There is a collision. You have to figure out where the user click. Something happens. State changes. Your node is selected. Maybe you need to schedule a refresh. Have some refresh reason. Wait for the next frame. When it occurs, it will occur in 60 frames per second. So in 16 milliseconds, probably CPU time. This is like ages. So when these ages pass, you will process the changes and update your GPU buffers, and finally call the render to draw these green pixels around your node, and user knows that they actually clicked the node. So events happen asynchronously. There will be different modules, very much decoupled, each handling different aspect of your visualization. And those modules, they will run in different environments, some of them on the main CPU thread, many of them in the workers, and some of them on the GPU directly. So they need to talk to each other, send events to each other, and expect that things are not happening in sync. Okay, first module that everyone would probably expect is the graph module. It's like a very simple graph database for your JavaScript library, and it just holds your nodes and edges, their attributes, their states, whether the node is selected or faded or hidden or whatever, and it surfaces some basic API to access and traverse the nodes. You can build this on your own, but I would recommend having a look at Graphology, which is a great open source project doing exactly this. And for starters, that's just fine. But now let's talk about the more serious stuff. Rendering. It's a graph visualization library after all. So we want a render module. We want to draw pixels, please. Okay. So this module is going to listen to different events, create appropriate refresh reasons, reason about what's going on, what should be visualized, optimize those refresh reasons, and control the main render loop depending on what underlying technology you decide to use. I would like to pause for the optimize the refresh reasons. So let's imagine your user is going to select a node, then fade it, then color it blue, and then size it, and finally delete it. And all of this happens within one frame. So you can basically throw away all your refresh reasons, but the last one, the deleted, and process only that one. Okay, that's good. You can optimize the refresh reasons. What is the technology stack that you have at your disposal? You can use SVGs. SVG is running in basically DOM. It is very simple way to represent geometric shapes, and it gives you out of the box events and everything. And it's just great. It's really simple and flexible, but it's not very scalable. You can draw tens, hundreds maybe of nodes, but that's it. Then you're going to hit the limit. Next, you can use Canvas API, which is much better. It has a great performance if you optimize it a bit more. You can get some nice results. It has only a single DOM element, which is the canvas, and everything else you draw inside of it. That's all great. However, the events, the collisions, where on which node you actually clicked, you have to decide it on your own. So it's kind of half and half. And finally, there is WebGL or WebGPU these times, which has just the highest performance possible, but it's all up to you. You need to talk to the GPU yourself. So just like a slight overview table. If you really know you are not going to render more than certain number of nodes, and you're not going to, need so much, you don't need to go with WebGL. But I would go with WebGL. Right? Your users do have the hardware, and you can squeeze a lot of power out of that hardware. So let's go with WebGL. The rendering pipeline is complicated. And it would be for an entire semester to figure out how to do this. Um, in to summarize it, basically, if you want to draw something, you draw a triangle every time. So you specify the vertices, and then you start placing them onto the screen. You send all the vertices onto your GPU, and all the other attributes, states, colors, whatever textures that you want. And those vertices are going to be processed. They are positioned based on your camera somewhere, and then they are rasterized. They're cut into these little fragments, the pixels, future pixels. Fragments are basically wannabe pixels, and they're pixel candidates. So then comes the fragment processor that will process those fragments and figure out what is supposed to be the final color of the pixel. So on GPU, you have these programs that can draw something. They are always like inside of one program. There is vertex shader and fragment shader, and these two together, they work in order to draw you a node, maybe. All right, important thing to realize. There is a huge chasm between your CPU and GPU. Those two worlds are separated by hardware gap, right? So it takes a lot of time and effort, and it is expensive to transfer data from one side to another and back. So you need to be mindful when doing this, and ideally load everything in advance and then just send as little as possible. And if this wasn't enough, WebGL doesn't render text for you. So in HTML, you just say, okay, this is a div, put the text inside, and it will render it. In Canvas, very similar. In WebGL, there is nothing like that. If you want to render text, what you would do is take your paragraph, split it into words, split the words into letters, and those letters then map into rectangles. For each letter, you would create a rectangle based on two small triangles, and each of those rectangles knows what the letter is by mapping it to a texture atlas, so-called texture atlas, where you would put all the different letters that you can use in your font, in your alphabet. And to make it even more fun, from playing video games, you maybe remember when you come too close to an object, the texture on it becomes a little bit blurred. It's not as nice and as sharp, but you want your text to be razor sharp. So instead of just sending a black and white image, you would send SDF, a signed distance field. This is a special way how to encode characters, and each pixel encodes the distance from the edge of that shape, from the edge of your character. And then the shader can basically and like decode this information and draw you a sharp character, which is perfectly sharp. Sometimes if the resolution is too small, it can create some artifacts, but it is much better than having like going without it. Lastly, don't forget the right to left languages. Hebrew and Arabic are everywhere, and yeah, well, you would need to draw them one day. And it's not just right to left, it's bi-directional, because you can have some Arabic name, then maybe some number, and then another Arabic name. So it goes both ways. A lot of fun to render text. All right, enough about rendering. We are getting out of time. 8 minutes left. So let's look at interaction module. The interaction module, you would definitely need something like this. You need to capture mouse and touch events and key events, and have some custom logic to process those events to know what actually happens to the graph. But there is one important thing, and that is the collision detection. So imagine you have 10,000 nodes like this, and the node is not just a circle, it has a label, some badges, some different colors, and you want to know exactly where the user clicked. You cannot iterate them, that would be too slow. So instead, you need some spatial index. You need some structure like quad tree or KD tree to access those items in a logarithmic time. And that way, for even slight hover or movement, you can detect the collisions very fast. If you decide to use just the WebGL rendering, you can use some GPU-based methods like drawing into stencil buffer or something else. But yeah, the interactions and having some spatial index is going to be crucial. Last big module that we will have a look into is the layout module. Layout is an algorithm that arranges your nodes in a nice way. And as simple as it sounds, it is a hard and unclear and difficult to measure problem. It is very time demanding and resource demanding. If we are talking force layout, this is a physics particle simulation. It's not deterministic, it's iterative, and you don't even know when to stop, right? You need some heuristic to figure out, is the quality enough so that we can stop? And for sure, it shouldn't block the UI. It should run in web workers or directly on the GPU. And there is a lot of fun. We spent an entire year developing a few layouts. Important thing to say is that the academic research really did a lot for us, like so much. There are papers since 60s, I believe, research spanning from universities in Japan, Germany, France, United States, you name it. It's crazy how much work has been done on the topic of graph layouts. And yeah, you would have to go with some kind of research-based development. It's not like in 1 month you should deliver this functionality. No, you will just look at different algorithms, try to implement them, try to combine them, try to find out something that works for you, your users, your use cases. You will for sure need some layout testing app or testing framework, because there is a ton of you know, little parameters to tweak to figure out how to settle on something that is going to work and that's going to be nice. So product managers, they love it. You never know when the layout is going to be done. Let's have a look at the main layouts now. The force layout, as I mentioned, it's a simulation. There, the nodes repulse each other and they attract each other via these edges. There are a lot of aspects to it. For example, this node is larger, it has a greater repulsion, it has a high degree, which also means it has a greater repulsion. And you can accelerate this process easily. Well, easily. You can accelerate it by doing various techniques. For example, running the whole thing on GPU, and your GPU has a ton of power and can run all the iterations at once. So that, well, not all the iterations, all the forces, apply all of them at once, let's put it this way. Or there's also a way how to do like level of details, do different multi-levels and simplify the graph until it's really simple, and then start from the simple one and grow until it's really huge. and this would help enormously. The hierarchy layouts, they are the topic for itself. A lot of different layouts. You can have tree layout when you select one or multiple roots. Interesting about this image is that it has the leaf packing to save space. This is very efficient. A flow layout is optimizing the directionality of your edges. Also great for UBO use cases, for example. Or if you draw the layers in circles, you can get some kind of radial layout. There are two more that I would like to emphasize that don't get enough attention. I think there is a component layout. So I have seen it so many times. Graph visualization with like fragments, little components just flying around everywhere. Like at least our clients don't want to see that. They want order. They want to know what they're looking at. So it's great to just put the components in some rows, in some tables, put the same ones, the structurally similar together so that it is clear for the analyst what they're looking at. And then, in my opinion, the most difficult out of all of them is the partial layout. Imagine you have something on your screen, you double click a node, you want to expand it, see all its neighbors, but you're a strict analyst. You don't want your stuff to move, right? So you need to find an empty space, a reasonable empty space, where you would position the new nodes. Yeah, our clients hate when things move on their canvas without their will. And if you spend enough time and effort, you might get into something like this 13,000 node graph laid out under 5 seconds on the GPU. Last two things to wrap up. The animation module, it is important. It's not that animation is just, something fancy, something nice. No, it is a functional component. It is important functional component because you need to lead your user's eyes. For example, here at time 0, you got these nodes, then you have these nodes. And if you didn't have an animation, you don't know whether they moved like this or like this. It's crucial to know what the animation leads, what was the before state and after state. It's specifically for layout updates or camera movement or even attribute animations. And don't forget the CPU and GPU cousin, right? You cannot send all the positions every time there and back. Finally, grouping module, you can virtualize it and have like entity resolution groups in one, or attribute based, like all the people with blue hair in one group. Sooner or later, you will want to draw your graph on map. You can do it side by side, have a specialized map and specialized graph, or you can just take your graph and smash it on top of the map and just say, okay, we've got the functionality, or do something else. Just put the graph items inside of the map directly so that they can interact with the other items in the map, and just have this native graph, which is greatly synchronized with your like regular graph. So there is much more and many topics and specialized modules, but as an overview, I think this is enough. We are also out of time, and thank you for your attention. If there are any questions, feel free to contact us at graphaware.com or via LinkedIn.